Physics is the fascinating study of matter, energy, and the fundamental forces that govern the universe. Imagine for a moment that everything around you, from the tiniest particle to the vastness of galaxies, is in a constant dance dictated by the laws of physics. Let's dive into some of these concepts that shape our reality. First, consider gravity. It's the force that keeps our feet on the ground and governs the orbits of planets. Sir Isaac Newton famously described gravity as an attraction between two masses. The apple falling from the tree wasn't just a stroke of luck, it was a demonstration of this universal force. But gravity isn't just about falling apples. It's the reason the Earth orbits the Sun and why the Moon orbits the Earth. The gravitational pull is what keeps our solar system in harmony, and without it, we'd be lost in the vastness of space. Now, let's shift gears to energy. Energy comes in many forms: kinetic, potential, thermal, and more. Kinetic energy is the energy of motion. Think about a car speeding down the highway. The faster it goes, the more kinetic energy it has. On the other hand, potential energy is stored energy. Picture a roller coaster at the top of a hill. It has maximum potential energy, and as it descends, that energy transforms into kinetic energy, giving riders that exhilarating rush. This transformation of energy is a fundamental principle in physics, illustrating the conservation of energy. Energy cannot be created or destroyed, only transformed. Next, we have the concept of forces. Forces are pushes or pulls that can change the motion of an object. Newton's 3 laws of motion describe how objects behave when forces are applied. The first law states that an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. This is why a soccer ball won't move until you kick it. The second law introduces us to the relationship between force, mass, and acceleration, expressed in the equation F equals ma. This means that the greater the mass of an object, the more force you need to accelerate it. Finally, the third law tells us that for every action, there is an equal and opposite reaction. This is why when you jump off a small boat, the boat pushes back, causing it to move in the opposite direction. Let's not forget about the wave-particle duality of light. Light behaves both as a wave and as a particle, which is a concept that challenges our traditional understanding of physics. When you shine a flashlight, you're sending out photons, which are particles of light. Yet, when you observe light passing through a prism, you see it bending and spreading out like a wave. This duality is a cornerstone of quantum mechanics, a field that explores the behavior of particles at the smallest scales. Finally, consider the concept of relativity. Albert Einstein revolutionized our understanding of space and time with his theory of relativity. He proposed that time is not a constant, it can stretch and compress depending on how fast you're moving. This means that if you were to travel close to the speed of light, time would pass differently for you compared to someone on Earth. This idea has profound implications for our understanding of the universe, including black holes and the expansion of space. Physics is not just a collection of formulas and theories, it's a lens through which we can understand the world around us. From the smallest particles to the vast cosmos, physics connects everything in a beautiful tapestry of interactions and phenomena. So the next time you see an apple fall or watch a rocket launch, remember that you're witnessing the incredible principles of physics in action.